All right, in this video, we're going to be looking at rational exponents. Now, another word that's similar to rational is fractions. And we are going to be connecting these two radicals here. So here's an example of a power. It has a fraction for an exponent. So the numerator is going to be the exponent, and this denominator is going to be called the index of the radical. So let's break down what all these things are real quick so make sure we're talking the same language. So we have the old square root symbol. It is actually called a radical symbol. Now the little number that's out in front there, that is called the index of the radical. And then the number or variables that you are square rooting or cube rooting or fourth rooting, they are called a radicand. Now in this example, we're going to be looking at cube roots. So the little 3 is the index, so we're looking at the cube root. So since 2 to the third power, or 3 factors of 2 shown there, equals 8, going the opposite direction, the cube root of 8 equals 2. Now, if you don't have an index on your radical, it's automatically assumed it's a 2, or square root, but we already know that. So quick example here, cube root of 64, or the third root of 64. So that's going to equal 64 to the 1/3 power. Now remember, when we're looking at, we have a power and we want to switch it to radical form, the denominator is going to be the index, or going this direction that we just did, the index becomes the denominator of your exponent when you write it as a power. Here's another example here, 4 to the 1/5 power. We're going to change that into radical form. So here we go. That's going to be the 5th root of 4. So again, the denominator of the fractional exponent is the index when you write it as a radical. So for this example, we're going to be rewriting 6 to the 2/3 power in radical form. So here we go. So here's our radical, and then the base of your power is the radicand. That's the number underneath the radical symbol, what we used to call the square root symbol. Now the exponent is going to be the numerator of the fractional exponent there, or the rational exponent. And then this 3, that's the denominator. That becomes the index of your radical there. Now, there is another way of writing it. We can write it this way. So again, 6, the base, becomes the radicand underneath the radical, and then the exponent's going to be a 2, and then the index is the denominator of that exponent. Here, let's evaluate 81 to the 3/4 power. So we can rewrite this in radical form. So in this case here, we're going to have 81. It's the base for the exponential form, and it's going to be the radicand in radical form. And then we have an exponent of 3. So the numerator becomes the exponent, and then your denominator becomes the index. So now we can pull out a calculator. This one definitely is going to need a calculator to continue to evaluate this. So here we go. So we're going to leave the index of 4, and then we can do 81 to the 3rd power. 531,441. And then we're going to do the 4th root of that. So if you have a calculator that does that, go ahead and do that. If not, you can take this and raise it to the 1/4 power on your calculator, or 0.25. Now this way made the number super big, so we can actually do it another way that makes it simpler. So let's change it to this form instead. So there's our index, that's the denominator, and then our power is the numerator of the exponent. Now this is a little bit easier to do. 4 3s, 3 times 3 times 3 times 3 makes 81. So we can simplify this, and it makes it a smaller number, easier to work with. And then 3 3s being multiplied, 3 times 3 is 9, times another 3 makes 27. So 2 different ways of getting that number or value. Here we're going to go ahead and rewrite this expression. It's in radical form. We're going to rewrite it in exponential form. So we have the 7th root of x cubed. So our base is going to be x, And then for our numerator in our exponent, that's going to be the power or the exponent here. So that's going to be a 3. And then the denominator matches with the index. So x to the 3/7 power is the same thing as 7th root of x cubed. For this example, we're going to rewrite in exponential form. This is the 6th root of a to the 4th, b to the 5th. So our base for the exponent would be a to the 4th, b to the 5th, the radicand there. And to what power is that going to be? Well, the index becomes the denominator of your exponent. So here we can continue to simplify. We're going to use the product to a power property of exponents. So this 1/6 is going to go both to the a to the 4th, and it's also going to go to the b to the 5th. It's kind of like the distributive property. So here we go. So that's going to be a to the 4/6, and then we're going to have b to the 5/6. When we multiply a whole number times a fraction, numerator times numerator, 5 times 1 makes 5, and then we can kind of pretend that's an over 1 there. 1 times 6 makes 6. Now we can clean this up a little bit more as well. So 4/6 reduces to 2/3, and then the 5/6 can't reduce at all. So just remember, when we're working with these, when we have fractional or rational exponents, the denominator becomes the index of your radical, and vice versa, and then the numerator of that fractional exponent becomes the exponent of your radicand.